Today we are going to show 4 examples of solving one-step inequalities and also graphing and checking them. Okay, so let's get started. Let's start by titling our page, Solving One-Step Inequalities. Okay, you'll want to make sure you have a ruler handy, as when we graph, we want our number lines to be on straight lines. All right, our first example is going to be an example when we're solving a one-step equation with addition. So we have m plus 3 is greater than 8. Okay, so just like before when we were solving equations, we're going to isolate the variable using inverse operations, so undoing the math. Okay. So to undo, add 3, we're going to subtract 3 from both sides. Okay, my addition of 3 and subtraction of 3, those cancel, and then I'm left with m is greater than 5. So up here, we needed to know what values of m could I add to 3 to give me a number bigger than 8. And the values of m that I could add to 3 that would be greater than 8 would be anything bigger than 5. Okay? Now grab your ruler. When we draw number lines, we want to make sure that we have a nice straight line with arrows on both sides, because this shows that we are going on in both directions. And with the number line, we talked in class about how we don't have to have 0 on every single number line we're working with, but what is really important is that m being greater than 5, the number 5 definitely needs to be on the number line. So my recommendation is to have 5 to 7 intervals there to kind of look at. So I'm going to mark these as 3, 4, 5, 6, 7, and 8. In order to graph, m is greater than 5. Remember, if it's greater than 5, it doesn't include 5. So I'm going to have a circle around 5. And if m is greater than 5, then it means all of the numbers more than 5. So my arrow needs to point to the right. Now, in order to check my work, okay, I need to look and say, well, what numbers over here does that include? All of these ones, right? So I'm going to use the very first one that pops over here in 6. I'm going to check to see if m plus 3 is greater than 8 when m equals 6. And if this is true, then I know I have my inequality pointing in the right direction. So m plus 3 is greater than 8 when m equals 6. And I'm just checking to make sure that m equals 6 satisfies my inequality. Now remember, whenever we're using substitution, we rewrite the inequality, substitute, simplify. So 6 plus 3 is greater than 8. There's that substitute. And then simplify, 9 is greater than 8. And then if 9 is greater than 8, I can put a check mark and know that I have my inequality point in the right direction. Let's try an example where I'm subtracting. Okay, push this up a little bit. So 1 is greater than or equal to a minus 7. Okay, so I'm going to draw the lines around the inequality symbol. Okay, this keeps me organized. It also makes sure that I keep my symbol away from the other numbers, because sometimes inequality symbols can look like numbers, like up here it could be a 7. Now I'm going to use the inverse operation to undo the math. So I know that in order to isolate the variable, I'm going to add 7 to both sides. And when I do that, 1 plus 7 is 8. Drop down my greater than or equal to sign. The 7's cancel, and I get a. So 8 is greater than or equal to a. Now remember, we can read inequalities 2 different ways. If I read left to right, my inequality says 8 is greater than or equal to a. If I read right to left, my inequality says a is less than or equal to 8. And I could rewrite that. If I want to switch the sides, I'm going to put a on this side. I'll put 8 on this side. And don't forget that I'm going to switch my inequality symbol. Okay. You may want to do this. You do not have to do this, but this might help you when graphing. So again, okay, draw your number line. Okay, 5 or more equal intervals, making sure that 8 definitely lands on my number line. Okay, now if a is any number less than or equal to 8, I'm going to put a closed circle on 8. Okay, and since a is less than or equal to 8, it's going to be all the numbers to the left. Now let's check. When we check our one-step inequalities, we're going to rewrite the inequality, substitute, and simplify. So I need to check one of the numbers that's underneath this line here. It's underneath the hood, okay? The next number that I see is 7, so I'm going to rewrite my inequality. When a equals, this next number here is 7. Now I'm going to substitute. Now I'm going to simplify. And I'm going to have that 1 is greater than or equal to 0. Since 1 is greater than or equal to 0, I know that I have my inequality pointing in the right direction. Okay, the next one that we're doing, we are going to try multiplication. So we are going to do 5r is greater than or equal to 20. Okay. In order to solve, we want to make sure that we are drawing the lines around the inequality symbol, and we need to operate on both sides. Okay, here we go. First thing that I need to do is I need to undo the multiplication that's happening over here. So I need to undo multiply by 5. I undo multiply by 5 by dividing both sides by 5. The good news here is that 5 divided by 5 is 1. 1 times r is r. And since r is greater than or equal to 20 divided by 5, which is 4, it means if I wanted to multiply a number by 5 and make sure that number was at least 20, the number I multiply by 5 needs to at least be 4. Okay, so let's draw our number line and check. Okay, so remember, I don't have to have 0 on my number line, but the one number that does need to be on my number line is 4. So I'm going to go 2, 3, 4, 5, 6. Okay, zoom in a little bit. Since I'm greater than or equal to 4, or at least 4, it includes 4, I'm going to have a closed circle. Okay, I need to go to the right to include the numbers greater than 4. When I check my work, okay, I'm going to rewrite the inequality 5r is greater than or equal to 20 when r is equal to, so I come back down here and I say, okay, what's the first number that comes under the hood? And it looks like 5, so I'm going to try r equals 5. So I do 5 times 5 is greater than or equal to 20. Now I'm going to simplify, and 25 is greater than or equal to 20. Now, if this is a true statement, if 25 is greater than or equal to 20, then I have my inequality pointing in the right direction. All right, our last example will be division. We will do n divided by 2 is less than, let's do 9. Okay? All right, so after I draw my bars here, I want to be thinking about what math is happening to n. And I notice that n is being divided by 2. In order to undo divide by 2, the inverse operation to divide by 2 is to multiply both sides by 2. When I multiply by 2 and divide by 2, I know that those cancel, and I'm left with n is less than 9 times 2 is 18. Okay. So that means if I want to divide a number by 2 and make sure that it's less than 9, well, then my number that I'm dividing by 2 needs to be less than 18. Let's go ahead and graph. Okay, so I'm going to start here at 16, 17, 18, 19, 20. Since I need n to be less than 18 but not include 18, I am going to put an open circle around 18, and since it's going to be less, I'm going to go to the left. Okay, so let's check our work. N over 2 is less than 9 if n is equal to, now I could choose 17, but I noticed that 17 divided by 2 gives me a fraction or a decimal, which is fine, but to make my mental math a little bit easier, I'm going to pick this even number 16 to make mental math happy. So I'm going to substitute 16. When I do that, 16 divided by 2 is 8. And 8 is less than 9. Since 8 is less than 9, then I know I have the inequality in going the right direction.